A system of equations doesn't only have to involve two variables, an x and a y. It can involve more variables. In this example, we have three variables, x, y, and z. So we're going to solve this system by finding the x, y, and z values that make all three equations true. And the first method we're going to solve three variable systems, we're going to use substitution. To use substitution, we start by solving one equation for one variable. Again, it doesn't matter which variable, and it doesn't matter from which equation. We want to pick the easiest variable to solve for. Step 2. Take that equation and plug it into one of the other equations. And then simplify. And when we simplify, we want to write that equation in standard form with our variables on the left and our constant on the right. Step 3. Plug the equation that we found in step 1 into the final equation and simplify. And when we simplify, we want to write that equation in standard form. So now we have two equations, both in standard form. And both of these equations should have just two variables. So at this point, we need to solve the two-variable system. Once we've solved that two-variable system, we're going to know two variables. We're going to take those two variables, plug them into the equation from number 1, and get our third variable. Once we have all three variables, just like in a two-variable system, we want to check our answers. Let's go through this process on this example problem. Step number 1. Solve one equation for one variable. I can pick any equation and any variable. I want to pick the easiest one to solve for. In this case, I'm going to pick the x in my second equation because the coefficient here is 1. I can solve for the other variables, but it would be a little more difficult because I'd be working with fractions. So I'm going to take the second equation and solve for x by subtracting 2y and adding 3z to both sides of my equation. So I know that x equals -3 minus 2y plus 3z. So step 1 is done. Step 2. Plug that equation into another equation. So I'm going to pick one of the other equations and plug this equation for x into those equations. I don't want to plug x back into the equation that I've already used. I want to plug it into the other ones. So I'm going to start with the first equation. Replace the x with this. Keep everything else the same. And simplify. So I'm going to distribute. Combine my like terms. So I have -4y and -5y gives me a grand total of -9y. 6z plus 4z gives me 10z. And I want to write this in standard form, so I want to get rid of this -6 by adding 6 to both sides. So I'm left with -9y plus 10z equals 19. Step 2 is complete. Step 3. Take that equation from step 1 and plug it into the remaining equation. So I used equation 2 in step 1. I used this equation in step 2. Now I'm going to finish off with my last equation. replace the x with negative 3 minus 2y plus 3z. Keep everything else in the equation the same. Simplify by distributing first. Combining my like terms, I have a grand total of negative 6y's and positive 14z's. And I want to add 20 to both sides so my equation is in standard form. So I'm left with negative 6y plus 14z equals, excuse me, there should be a 15. I was already doing the math in my head. Grand total of 20. The whole point of doing these first three steps is to take a 3-variable system and knock it down to a 2-variable system. So step 4, I'm left with two equations that only have a y and a z in them. If you notice, my x's are gone. So I've simplified my 2-variable equation down to, or 3-variable equations down to 2-variable system. So now I can solve this 2-variable system using any method. Well, in this case, there's no variable that I can solve for easily. So I'm going to use linear combination. I'm going to try to eliminate my y's. I could just as easily try to eliminate my z's. My coefficients for my y's are negative 9 and negative 6. So the least common multiple between negative 9 and negative 6 is 18. So I'm going to turn my first equation into a negative 18 by multiplying by 2. And I'm going to turn my second equation into a positive 18 by multiplying by negative 3. (14 times negative 3 gives me negative 42 z and negative 60. Now I need to add. The whole reason I need opposite coefficients is so that my y's disappear, and I'm left with only z's. So I have negative 22z equals 38 plus negative 60 gives me negative 22. Solve for z. Z is going to equal 1. So now that I know z is 1, I can solve for y. I have two equations that have just a z and a y in them. I'm going to use one of those two equations, plug z in, to get my y. So I'm just going to pick this first equation here. Negative 9y plus 10z has to equal 19. So negative 9y plus 10 times 1 has to give me 19. So negative 9y plus 10 has to be 19. Negative 9y has to be 9, which means that y has to be negative 1. So I know my z and I know my y. Now step 5, I need to solve for my remaining variable. In this case, it's x. So I need to find an equation that has an x in it and a y and a z. I could use any of these equations, but I have a really nice convenient equation from step 1 that involves an x, a y, and a z, where x is already solved for. So I can just take that equation, x equals negative 3 minus 2y plus 3z, and plug in my y value, which is negative 1, and my z value, which is 1, and then solve. So I'm going to have x equals negative 3. Negative 2 times negative 1 is positive 2 plus 3, which gives me a grand total of 2. So finally, step 6, I'm going to check my answer. I'm going to write my answer as an ordered triple. And I'm going to list my variables in alphabetical order. X, Y, Z. When I just have an X and a Y, that's called an ordered pair. When I have 3, this is called an ordered triple. Now I want to use my calculator to check my answer. I'm going to scroll up to my original equations, and I'm going to plug my X, Y, and Z value in to make sure that I get this answer. I get a true equation. So I have 2 times 2 minus 5 times negative 1 plus 4 times 1. And I do get 13, so it works in my first equation. But I need to make sure that it works in all 3 equations. So I'm going to hop to my second equation. 2 plus 2 times negative 1 minus 3 times 1. Yep, works in the second equation. Let's make sure that it works in the third equation. Yep, I get 5. So in order to solve a 3-variable system using substitution, we need to knock that 3-variable system down to a 2-variable system by solving for one variable and plugging it into the other 2 equations. Once we have a 2-variable system, solve that 2-variable system to get 2 variables, which we can use those 2 variables to figure out our third variable. Finally, check your answer.